All right, we have started the recording, so it should be recording. Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. Um, if you remember correctly, at the end of last week's streams, I said that I kind of came upon the fact that I really didn't feel like I had a solid understanding of exactly what the right sorting rule would be for our game. And this is kind of a aspect of my inexperience with 2D games. I'm really more of a 3D game person. I've never really worked on 2D games or 2D game technology. I've only ever worked on 3D stuff, so I just don't have a lot of sort of like tips and tricks for like, oh, here's probably how you want to sort sprites, or here's the best way to sort of like, if you're trying to fake a 3D effect, here's, maybe the most efficacious way to do that. And so, I really just don't feel comfortable yet specifically saying this is the way that this should work. And so what I wanted to do today, because I just, at the end of last stream, I was kind of playing with it, and I was like, I just don't feel comfortable here. I don't feel like I really understand what the trade-offs are. I don't feel like I understand what the rules should be, or what would produce the best outcome for us in most circumstances and lead to the fewest hacks. So I decided that I just wanted to spend today's stream figuring out what I think about Z-sorting for a game of this fashion. And so that's really all we're going to do today. And I mean, if we come up with something relatively quickly, then we'll just try and start putting that into code. But if we don't, then we don't. So it's really just a case of trying to work that through and giving ourselves enough time to get to a point where it's like, okay, this seems pretty reasonable. So here's day 299. And we are talking about tile Z sorting. Now, for the moment, the part that I'm concerned about is only sorting within a layer. So I'm going to go ahead and assume that layers can be sorted separately, and our rooms are kind of in those slices that you saw, where they're kind of discrete sort of pieces that are faded in separately and other stuff like this. But inside a given room, I want to think about how the tile Z sorting should work. And the way that I started thinking about this, because I was kind of thinking about it a little bit today, was just that we could say very clearly that if we were looking directly top down on something, right? So let's say that we were 100% top down. So here is like our tiles, right? If we were directly top down, then what we would know is that, looking at it, here's our sort of our camera, and here's the tiles, right? So we're looking kind of this way down at them. What we would know is that the Z value would be all we would sort on, right? Basically, we would know that whatever the topmost Z value is of a character or a sprite, whatever its highest Z point is, that is the point that we would sort on. Because since no two tiles will ever overlap each other, they will only be like higher or lower, we only care about sorting things that are stacked on top of each other, and obviously when things are stacked on top of each other, the highest possible Z point is the point that tells us what would be viewed, right? So then we get to sort of the second stage of that, which is what happens now when we tilt that slightly. So here was previously, the way we were looking at things. Here is sort of an example of something that we might be seeing from the top down. And so in this circumstance, if the hero is standing here, then what I see when I'm looking top down is that, well, the hero's highest point is here, the cloak's highest point is here, the torso's highest point is there. We can sort all of those by Z. Here's the highest point on the ground. If we sort the highest points by Z, we will immediately get the correct answer. And since we never really care about any other aspects of it, we don't have a problem. Now, is that 100% true? No, it's not 100% true. And why isn't 100% true? Well, it's not 100% true because we don't really have the opportunity to do this sorting in a way that is partial, right? Because if you think about what's going to happen, we're really not going to get a perfect set of tiles like this. We're going to get sprites that kind of overlap a bunch of tiles, right? And so we don't necessarily always have the luxury of, of doing sort of whatever might be the most sensible thing to do here. Well, you know what? Now that I think about it, though, I don't know. That might also be kind of correct most of the time, right? If this thing was higher than the thing we were sorting, then it would clip it and so on. So I don't know. That actually might also be fine, right? So I take that back. I think we might always be fine because it'll sort separately for each of those, right? Because we're sorting each of those 4 tiles plus the guy separately, right? And furthermore, there are some cases that people brought up, like let's say we have a rug that went across all of these. Well, again, exact same thing should work properly here. The rug would sort relative to these tiles. Any tiles that were higher than the rug in Z would draw in front of it, and any that were lower than Z would draw behind it. And although that may seem nonsensical, because like, hey, what you don't really want a rug be clipping into a tile. Well, that's what should happen. If you've created a not really possible world where a rug is sticking directly into a tile that's sticking up, well, that's not the renderer's fault. So I feel like top-down is very straightforward. Top-down is just sort by highest Z point. So where does the complication come in, right? The complication comes in here, and I guess, you know what, let me go ahead and draw this maybe a little bit, just slightly differently. And maybe, you know what, I could do it by going like this. So the complication comes in just when we're doing this sort of thing, right? So now, when I'm drawing this, I get a situation where the sorting by the highest Z is unfortunately not going to always give me the right answer. And the reason that sorting by the highest Z is not going to give me the right answer is because this guy is obviously the highest, but he would actually be drawn last in this scenario. And the reason that he would be drawn last is because this angle that I've taken on the world allows the viewing ray to encounter these things here, right, before it encounters these things back here. And you can just sort of see that would always be the case, right? There's really nothing, there's no way there's really no way to sort by just Z and see that that's happening, because the activity that you're concerned about is happening in a different dimension, right? It's not happening in the Z dimension, it's happening in the Y dimension, assuming again that this is kind of rotating here around X, right? So it's rotating kind of into the Y plane. But the sort of the trick that I was hoping to rely on before, and maybe we still can, but I'm just going to try and sort of elaborate on what it kind of was. The trick that I was hoping to sort of work with before was the fact that we can know that because we've tilted the camera in this way, that there's a strict ordering of things where the closest things are going to be the lowest things in Y, right? So this is going to be closest, and this is going to be furthest, right? So in theory, it would seem that if we sorted by Y first, and then by Z, that might actually solve our problem. And I would go a little bit further and say that the closest to furthest sorting, we could also, and this is, I think, something that I missed when we were thinking about it on Thursday. One of the things that was tripping me up is, well, when you have these continuous moving pieces, like entities, right? Then it gets kind of confusing, because you end up with these sorting problems where it's like, well, how does this guy sort relative to, this thing? And what I realized is we could actually get around that fact potentially by quantizing you to the tile that you're in, right? And so, in other words, we could say, well, there's a sort, and the sort quantizes you to a tile. So you're always considered to be at a tile center when we do the sort. So no matter where this person moves on here, it will always sort inside this column. And then inside this column, we could still sort by ascending Z. And I don't know why I thought of that. I thought of that today when actually Anna and I were taking a look at some of the art stuff. It just kind of popped into my head. I was like, huh. And so I think there's something to that. I think what maybe the part was that I was missing is, since it does appear to be true that absent any other information, you know that you can always draw in this order, right? We know that we're always going to encounter these things before we're going to encounter these other things. maybe really what we need to do is just say, okay, we need to quantize people into tiles and sort them inside the tiles, because that's really the only way that we can, that we can make sense of what should be happening, right? And the other part that's kind of interesting about this, right, is that if we assume that everything was contained within a tile, I think that would work. So I think that if everything was quantized down to a tile and everything was roughly tile sized, then we would have pretty reasonable sorting. So the part where that starts to break down is the case that we were talking about. Sort of, someone brought it up on the post-stream Q&A. The problem with doing that is what happens when you have objects that don't really do that. So let's suppose we have a table or something like this, or I guess a better example that was brought up before was like a rug, so that someone could actually more plausibly be on top of it, right? I mean, maybe characters don't generally stand on tables unless everyone's drunk, but assuming that we have something that's like a floor covering. Well, the problem that we get there is we could easily still write the quantization rule that probably makes this work correctly, and that quantization rule is just to say that it should be sorted along with its frontmost tile, whatever that tile might be. It doesn't really matter which one we pick because X is irrelevant here, so as long as it's a frontmost tile and Y, that's fine, and we can quantize it to like that row. But the problem that we run into there is then it will draw in front of anything that's in this back row, and that's not actually what we want. We still want this thing to be sorted relative to these other tiles, right? We just want it to be sorted such that it covers over those tiles but allows other people on those tiles to be standing on top of it, right? So that's a little bit confusing, and that I think is the part where I'm a little bit hung up. And I think that's because once you start linking those stacks together, now you have a case where you have to say, well, now I really can't say that everything that's here is always drawn in front of everything that's here, because really this thing is sort of kind of goes across all of them and creates this sort of weird cross-cutting concern. So I don't really know what we do about that, right? I mean, one thing we can do about it, obviously, is we can try to create some kind of a special sort system that, takes these things into account. But what would be nice is if there was some way to sort of, if there's some way to create a rule that would be intelligent about how these things are picked up. So, let's suppose, for amusement's sake, let's suppose that we want to start taking this into account in a more systematic way. What I was thinking is somewhat plausible, is we could start to think of the sort as a little bit more Painter's algorithm-y, right? We could think of the sort as something that was going to, what's the best way to say this? We could think about the sort that was something that was going to take into account sort of the way things extend, like the actual planes, and look at which one should be the correct one, right? Which order of drawing these things should be the correct order. So if we have something that's, a flat piece like this, and then we have another thing that's sort of standing upright on it, and we know that here's the Z of this guy, and we know that here's the Z of this guy, we know that he doesn't get higher as it kind of goes further up, because we have the information about sort of whether it's, what kind of a plane it is. And so that kind of gets us back to the upright versus not upright sorting. I don't really know if, and we could generalize a little bit to say, like, well, we give it a plane equation or something like this. But I don't really know if that's a profitable route to go down, right? It's sort of in the back of my mind. It's like, well, we could start sorting these things more real, but I kind of feel like we should be able to come up with more of a tricky, a more clever sort of way of doing this, right? But I'm just not sure what that is. So you can see if we enumerate the cases of this particular, of the rug situation, right? So here is the problem that we have. Suppose that we take those 4 floor tiles and now we place this rug on it. The rug is obviously an entity, right? And then standing on here is a hero element, right? This is a a hero. So what we would want to see, right, when we actually draw this thing, and let's say that we'll be more specific here. So let's say we give each of these things a letter. So there's, well, I guess I can't quite do it. So A, maybe I'll draw this a little bit bigger so I can actually label it. So here's A, there's B, there's C, there's D. And then we put on here an E, which is the rug, and then we put the hero, which is the F. Okay? So what we want to see happen in this case is the sort order we would like to produce always is we don't really care too much about the order of C and D relative to each other, or A and B relative to each other, but otherwise we have a pretty much complete ordering of how we would like to draw these things back to front, right? We would like to draw A first, we'd like to draw B second, or these are interchangeable, right? We don't really care about those. Then we have C and D, also interchangeable. Then we have E, and then we have F. That's the order we would like to draw them in. And with thinking about sorting things inside columns with quantization, obviously inside, if we just considered the tile B and we sorted it with that rule, everything would work fine, right? We would produce the sort of sort B, E, F, which is the correct subsequence for inside this tile. The problem comes when we're trying to figure out what happens in A, C, and D, right? And, you know, there is a single sort order for how these things have to be drawn, but each individual tile sort could have, in theory, produced something different. So although this tile sort is AE, which is, you know, and CE and DE, right, inside each of these, it does happen that that sort is all, can all be represented here, right? So I guess that's the part that's really kind of tricky, is it's like, if we were to produce a sort for every tile and then somehow merge those into a single drawing list, then in theory it would work, right? In theory that works. You obviously have the possibility for ambiguity here, or rather the possibility for a conflict, which is to say, let's say that the way this looked from a 3D perspective, right, was something more like this. So here is a block. This is the block A. We've got C, D, and B here, right? And then in here, we've got the rug that's on here, right? And A protrudes straight up through the rug. So the rug is actually interpenetrating, right? Well, if we had that situation, I mean, yes, it's sort of illegal, but I mean, you know, in a 3D rasterizer, we use the Z buffer, we just kind of like suck that up, right? So if we wanted to produce something reasonable, what we would see here is, well, in this one tile, even if we produced sorts for all the tiles, we would see that we had EA here, right? Electronic Arts, registered trademark. You'd see that you'd have EA there, and there is no way to really produce potentially the rendering order that you want. Because we said perhaps that we wanted C in front of A because it comes first in Y, but then now we're saying that E, which has to be on top of C, is coming behind A. So you have an impossible sort order. You can't have these two things appear in a particular order and these two things appear in a particular order if that order is different, right? That's just not going to work. And so even if we did do all the sorts, we could still end up in situations like that, and we would have to have some way of knowing how to resolve it, right? And it's unclear how we would do that. So I don't really know what the right solution is there. I mean, one thing we could certainly do is just break the sprites up, right? You could just straight up cut the sprites into pieces that get sorted separately. And, you know, is that an awful idea? Not necessarily, right? That could be a totally reasonable, thing to do. I don't know what the right solution is there. Um, I really don't. And I mean, one thing I guess I would say is this is why you don't tend to see a lot of 3D sorts of stuff in 2D games, right? Typically, you actually go ahead and do regular 3D for this sort of stuff, and that's the reason why, because there's really not a lot of. I don't know that there's a lot of clarity that you can really get from something like this. I don't know that there's a lot of. I don't know that there's an elegant solution to it, right? And so typically you end up just not doing stuff like that, right? You're like, well, we just don't allow floor coverings to go in that way, or we don't allow there to be height changes in the floor, so that way we know that we always just sort by Z and we're done. I don't know. So yeah, it's a little bit iffy. I'm not really sure what I think about it yet. And I can't say I'm really feeling particularly enthralled with anything that I've said so far in terms of like a key to a good solution. What I will say is that sorting everything by Z in purely top down really does seem like a very straightforward answer that does work pretty well, right? And I do wonder if perhaps that doesn't generally work pretty well. I wonder if maybe we can just do something where the Y component of things, maybe we can fold that into the Z somehow and it just sort of works. I'm curious if there's maybe something there that I'm neglecting that's actually a relatively simple solution, and I'm just not sure. But like I said, if you imagine kind of looking at this top down, wherever that was, over here. Well, I'll draw it again. So if we imagine looking at this top down, right, so here's our, and maybe I'll try to do this in a way that we can actually draw the actual heights of things. So if you imagine looking at this top down, and here's a hero, and then we sort of look at it more in a 3D setting, and maybe the hero is kind of down in like a bit of a pit. Right? And maybe there's like kind of a very tall one here. And it goes down to like a very short one here. So, if we were to look at this from here, and the hero, here's the hero kind of standing back in here. So the hero is like, there's like a dotted line kind of coming. Well, that's not a dotted line. Let's try that again. There we go. So if the hero's kind of standing over here, then can I erase? I don't know if I can erase. Eraser is E. Eraser is E. Brush is B. Oh my god, it's huge. How do I make tools tinier? Brush size. Let's get that a little tinier. There we go. All right. Lovely. So, assuming that the hero is standing here, and this is kind of what we're looking at, right? Then at first, when we're pure top down, again, sorting by Z, I think just works for most purposes. There might be some artifacts that that we might worry about a little bit there, but I think for the most part, that's probably what will be acceptable. But what's not good is once we start to tilt a little and view from the side, then this thing has to occlude here. Now, one thing that's true about that is that it's higher in Z. So it would actually sort properly. So this one is not really, I guess, so much the concern. The concern perhaps is more this one, right, which will sort in front of this guy, which we don't want it to. And so that's where the Y part of things comes in. if we do our sorting by Y, then we, again, I think we would end up with a reasonable solution here, because we would still have this, sort by Y and then sort by Z. This guy is still always above in Z of whoever he's standing on, so that's not a concern. And, yeah, so it seems like that would really just not be a problem. So I think, for the most part, sort by Y, sort by Z works for the things that are contained in the tiles. So if we then say, well, now we've got a situation where we want to extend something out that exists kind of cross tile-wise, and I guess, it seems to me like the only time that can really work, the only time that's really going to happen realistically is when things are flat, like when the ground is relatively stable. So, we're talking about a situation, I think, that has to look kind of like this. These Z values all have to be very close. Otherwise, you can't really put, you're not going to be able to put, a table or something on top of these if they're not fairly flat to begin with. So you're talking about a thing where they're already pretty flat, and then we're talking about layering on top of it something like a rug or whatever we're going to put on top there. So in that circumstance, where we layer on top of it, a rug or whatever is going to happen, then our problem is that Y sorting is going to make it difficult for us, because now we have a situation where the hero who's standing back here should always sort on top of this, because at the point where the hero is being sorted, the rug is clearly underneath them. But if we were to sort Y, if we're taking the Y into account, we end up in a situation where, this would have to be assigned out here somewhere in Y in order to sort in front of these tiles that it's clearly on top of. So yeah. So again, really kind of tricky. What we could maybe do here is, like I said, the planar sort of thing does make a little bit of sense. What we might be able to do is say, if we were to say what the plane was of each of these things, don't ask me what that crazy errant line was. If we were to use some sort of planar math for this, then what we could sort of say is, well, would this thing sort in front of this other thing at the point where they coincide, right? So we could say, well, the point where they coincide is here. Would it sort in front? The answer is yes, right? Well, that is okay in some sense. It's not okay in other senses. The reason why that's a little bit difficult is not because we couldn't write the equations to do it. The reason why that's a little bit difficult is because we also would have to clip things. And the reason that we'd have to clip things is, let's suppose that we then had some more stuff out here. This would sort in front of these, which I guess is actually, is that okay? I guess that might actually be okay, though. Well, no, okay, so take this other case, right? When we're talking about the tile, if you imagine extending this tile out to sort it against this one or something, as a plane, you would see that this was supposed to draw first, but really we want to draw this one first, right? Because we don't want these we don't ever want that one to sort of intercede, right? So I still just don't know. I don't feel like I'm getting anywhere on this. It feels like something where I can't think of what you can do besides actually start representing the things in 3D to cover that case. Now, maybe the right thing to do is just say, well, we can't do that then, right? Like we don't have the ability to do things like a rug on the floor that's done that way. Like it has to be done in tiles, right? But that does seem like kind of an encumbrance, because typically, you figure you're going to want to make a thing where there's, a sofa or something that spans two tiles, and you're going to want that to work. There's my top-down sofa. I suppose one thing that maybe would make sense. Let's think about this for 1 second. So suppose that we were to look at this in a little more like as an actual three-dimensional problem. And let's suppose that I took what was happening in that case. So I've got two tiles. Here's the center point of each of the tiles. I'm looking down on them. I then have a rug that's like, you know, stacked on top of it. And I've drawn them probably a little more separated than they would actually be in reality because I just wanted to be able to draw them both. You know, and I've kind of got this notion that there's the highest point on these guys or whatever. And then I've got a hero, and the hero is standing here, and his highest got a highest point. So when I actually want to go and look at these guys, if I am to look at their, you know, let's take some examples of like where they project, right? So the hero projects on here. You know, that tile projects like there, this tile projects like right here, and this guy projects right there, right on the line. So we would know what their sort of z value was relative to the camera, and the problem there, I guess, is that by, you know, depending on which point we would pick on one of these objects, right? You know, let's say we picked this point, it would sort in front of the hero, right? Whereas if we picked this point, it sorts behind the hero, and, you know, somewhere in between, it switches. So the problem with that, right, is that normally when we want to do some kind of sorting things, we know that we're doing it sort of per pixel, and so we don't have this problem of, well, which point do we pick to use for sorting when we're sorting versus the camera. Now, what we could do is look at the minimum and the maximum, I suppose, as well. So one way to look at to sort of talk about this problem a little bit differently, I suppose, is to look at the lowest point, right, and where does that project on? Right, and you can see that if we have sort of the extents, I mean, the other way to look at it is like the extents, like project the extents right onto here of the thing. We would sort of see when objects sort of encompass other objects. We actually do know by looking at two values from them, we actually would have that piece of information, right? And so I guess one thing we could say is, you know, looking at how this thing projects onto this other, you know, onto the line, maybe we can make some determination of that. So, you know, if we were to take a look at sort of the cases that can occur along this view line for two objects, right? You know, we've got object A and we've got object B. With their extents projected onto the view line, we have a couple of different cases. We have a case that looks like this. So they're disjoint. And in this case, where A and B are disjoint, then it would seem to me that there'd be probably no way that projected onto the view line that if A is always coming, if every point in A comes before every point in B, then one would assume that A always draws in front of B, right? Because that's the case where, like, you know, you've got this tile and it's always here and this tile is always here, so there's never any way that these, you know, this tile could never possibly appear in front of this one no matter what, right? We've got the situation where we have an overlap, right? So we've got A is here, right? And B is here. So they've got some area in common. And so that seems like a more ambiguous case, right? And then finally, we have the case where one is inside the other, right? So we have, like, for example, here is A, let's say, and B is actually the interior. So B is like sort of wholly contained in A. And so, you know, looking at these cases, right, when there's a slight overlap between the two, then, you know, that again is something that could come from, say, you know, the rug being underneath the person, right? We could have that for, like, let's say here's the rug. Oops. Here's the rug, and here's the human, and here's the view line. We would know that, like, okay, when we project the extents of this guy onto here, and extents onto here, like so, just straight project, just looking at literally just the z values, going down. We've got a case like this where here is our A and here is our B. And in that case, we would want to draw the, we'd want to draw the guy first, right? The guy is standing on top of this, so it should sort of appear over this. But if we were to slide it back, so if we were to put A over here, we would still want to draw, but now we've created exactly the same case, right? We'd still want to draw this guy first, but just by sliding this guy backwards, we've shifted it so that now it's the other way around. So looking at this case, it doesn't seem like there's really a lot of ways we can tell what was actually supposed to go on there, right? I mean, it doesn't seem like there's really all that much that we could do. Yeah. At least not that I can see. So I don't know that doing any kind of slicing in that fashion is really going to help us. I suppose, if we go back to sort of the concept that there's two sort of cardinal things, there's things that are sort of flat and things that are upright. If we look at something more like that, then you could maybe see how these sorts of cases would get resolved, because we'd have, here something where we've got, an upright card and a flat card. And the question is, well, how do we want to sort these two together? Well, knowing the extents of the upright card and the extents of the flat card, I think at that point, it probably isn't so hard to determine what should happen. Because since we know that this is an upright card, all we really need to probably determine there is to take a look at if we projected them out to where they both would meet, which one would be higher, right? So meaning, if we took the intersection of those two and we looked at is the z extents of this guy, how do they work when we actually look at the point where they would have in common? That would probably tell us the sort order, I would think. And that seems to get back to our sort of upright versus not upright. You know what I mean? Because really all that's doing is saying that well, what is that saying really? I mean, really, that's just saying that upright things have, are sorted via their z, whereas flat things are sorted via their y, in some sense. I say. I guess there is one more sort of way to start looking at this that I haven't really considered yet, which is that there's also just the notion of, I mean, for lack of a better term, there's sort of just the let's manually consider how the sort is supposed to happen. Yeah, I don't know about this. I don't see a lot of profit in this way of looking at things yet. I mean, without knowing the planes, and it doesn't seem like Painter's algorithms are going to help you there. Anyway, because since we know that YZ sorting would work for any, I think pretty much just works for things contained properly inside cells, because you can just sort the cells by Z and you sort the cells by Y and things inside the cells by Z. I feel like the only real problem we have is those things that span a cell. That's really the only problem that I feel like we keep coming back to, because there really isn't any. I don't think we have any problems with other things. So, one thing we could say is just, oh, maybe for those purposes, they're just, if there's stuff that spans, that's a cell of that size, right? Like the cell is that size. I don't know how well that works in practice. It does seem a little bit janky. I don't know how we would really pull that off. But then you would be able to do, that sort of stacking behavior correctly. Well, I really honestly don't see a lot of solutions to this. I'm not having the bright sorting idea. I feel like it really is down to only that case. Like, I don't feel like there's a lot of other cases. So I feel like sorting cells by Y and then inside cells by Z and then Y works, right? I mean, I guess it's worth noting that inside the cell, we still do have the problem of Y, right? So, if we allow, inside a single cell, here's a cell, if there's two things inside the cell, we need to know that the Y, like their placement in Y here, this is looking top down, that this guy draws second and this guy draws first, right? So I guess inside the cell we still do have a similar problem, right? Which is that we have to sort things by Y, but we don't really know what to do with things that are completely flat. Because things that are completely flat like that, we can use the trick I was talking about where the sort point is kind of back at the end of them or something like that. So we can, inside the cell, make sure that those are biased properly in that way or something like this. But it's not as simple as just sorting by Z if we also want to take into account intracell, like things that can be positioned intracell. Which doesn't happen that much, but for things like, maybe projectiles flying through the air, right? Since only one person can be sitting on a cell at a given time, it's not like there's two people stacked in the cell, but you still do have that problem of like little floaty things that float, flying projectiles, whatever. So I'm not sure about that. That does still seem also kind of nasty, right? How to get that sorting properly, because that's why we introduced originally that concept that there were upright cards versus not upright cards. It's like, oh, okay, we got to deal with that problem at some point as well. I feel like this is not coming together. I don't love it. I don't love it. I mean, I guess this is, like I said, it's maybe why I don't tend to program things in 2D, but I feel like there's got to be something you can do here that doesn't involve having to completely go all the way down to like a Z buffer. I mean, I guess we could just decide to start using a Z buffer, but then of course we also have to start treating these as like actually having 3D things that get rasterized out. Not to mention we're wasting all that bandwidth on the Z buffer that we wouldn't actually need, right? Because if we want to do early occlusion, we could do it with the alpha channel, I think. I don't know. I mean, my understanding of how generally this stuff works in sort of older things is that it's much more manual than this, right? It doesn't try to be dynamic with a lot of these things, and pretty much the heights of things were pre-programmed in sort of a very specific way. So it wasn't really an issue. If you had something like a rug, it was just known that it was on the floor baked into the bitmaps and so on, and didn't really need to be sorted in the same sort of way, right? So I guess one thing to think about here, let me draw one of those cases again, because I'm kind of thinking maybe I might have messed something up. Let's see here. So here's the view, looking down. And we're looking down on a rug. And a hero. Right? Now, if we were going to use a Z buffer, then the reason that we know that the hero sorts in front, right? Because this is really just an infinitely thin plane, right? In the case where we were doing this with 3D cards, we would just have this, right? So if we orthographically are projecting this against a plane, right, then, you know, like we're going to actually have the case I talked about before where we're going to be projecting these onto here, right? And it's going to look like that. And now the reason why we know that this guy appears above this guy is because at any given slice where this guy is, where he's going to appear on the screen, right? Because here's the area that he appears on the screen. The problem is that's the part that we need to know. If we know where he appears on the screen, he appears on the screen like right here, right? Here is where he appears. So we only care about the part of this plane that overlaps that. Yes. So that might be where we could go with this, Painter's algorithm-wise, right? We could say, well, let's ask the question, where is a point that these two have in common in this plane? Right? So in the when we're talking about viewing them, let's project their extents onto the x-axis, right? Because we know what their extents are on the x-axis. I'm sorry, the y-axis. Yeah. It doesn't really matter, I guess. Either way is fine. So if we were to project these onto one of the other axes, not z, right? And we found a place where they overlap. So we just say, okay, we'll project them onto the x-axis. So here we go. Here's the proposal. I don't know why I put the keyboard away. So I'm going to view along this axis. So here's my z, and here's my y, right? And this is my view z and view y, not the world z and world y, but we're talking about relative to the viewer here. If I now have my rug and I've got my dude, and I guess I'm going to draw these as actual cards. So here's the rug and here's the dude. Then if I was to project these back on to the y-axis, right? So if I'm going to look at just what their y coordinates are, so the min y and max y of this guy's card, right, is here, and the min y and the max y of this guy's card are here. So I know where the sprites are in y, right? Like I know what's happening there. So if I know a point that they have in common, which I do if they overlap. If they don't overlap in y, they don't have to be sorted, right? Like I don't really care how they're sorted in some sense, I don't think. Well, that's not true. If it's a total sort ordering, I guess I do sort of care. So if they're not overlapping, I guess I have to pick the closest point in common that they have. I don't know exactly how to do that. But anyway, I have to think about that. Right, because if I have two objects and I need to know how they're drawn relative to each other, if they don't overlap, then there is no rule for how they draw relative to each other. But that would cause potentially problems, I think, because I don't think you could pick arbitrarily, because there may be another object that overlaps both of them that would care how you sorted them, because it's going to go in front of or behind one of them, and then if you picked the wrong way for the other one, it doesn't have the opportunity to get sorted in there. So that's tricky, right? That's kind of nasty. So I don't know, that might also be a deal killer. But if we take a look here and I say, well, all right, I've got, in the closest point they have in common, which would either be where they overlap or if they're, disjoint, then the point in between their two closest extents, right? If I'm to look at that and I see on that one, where are they z-wise, each of them? So at this point, we've got here and here. That would tell me who sorts where, right? I mean, that's what that tells me. And for that matter, I guess also, now that I think about it too, you could think of these as sort of forming a space partition. So I guess, really, I wonder if you actually had everything categorized as these planes, could you just actually use the planes and test the planes themselves? In fact, that's obviously true, isn't it? I mean, figure this. If I've got any given plane and I look to see what side an entity is, which side of a plane it's on, if it's on the same side as the viewer, then it's closer to the viewer, right? It should be drawn first. So the only case that I end up having to worry about is if it's actually interpenetrating, right? So if part of it's on one side and part of it's on the other side, and if that's actually the case, then I guess you would just have to know, well, I'm trying to think of what is the tie-breaking rule there. In the case where they actually interpenetrate, there is no way to draw them correctly, so that's not really the concern. The concern is more like where they don't interpenetrate. So let's say you have this case, and in this case, I should be drawn first because I'm closer to the viewer here. So when they don't intersect, I guess maybe you would just say, I'm sorry, when they do intersect, but they don't actually overlap because of their extents. But when where their planes, where this plane would intersect this other object, then how would I know which one? So I've got two cases, like one case is here, one case is there. And I guess in that case where you don't have, it's not on clearly one side or the other, I guess it's, you just go the other way around, right? So you just test the other plane. I think that might work. I mean, like I said, it does require all of the sprites to have a plane equation. And that plane equation, I think, for our purposes, can always be either the world's, the normal to the plane would always be either the world z-axis or the world y-axis. So it's not like we ever have to actually do any work there. But if we're willing to do that, I think that's the sorting rule. What do you guys think about that? It's about time for the stream to end anyway. I did what I said I was going to do, which is try to figure it out. I think that's pretty solid. It would require every sprite to know its bounds, which it does. And it would need to know which plane it was, which it does. So I think that would work. And I feel like you could use approximations, like, if an object is thick, if an object looks like this, technically in the world, I don't think you need to represent like a plane here and a plane here. I think you could just use one or the other and it would probably be okay, I'm guessing. But famous last words, obviously. I suppose it really would depend to a certain degree on what sorts of objects you tended to have. Like, yeah, I don't know. I think that's the best guess that I can come up with at the moment. So let me see what you guys think of that so far. That was my thought process on it. Some people who watch the stream might have more experience with 2D game hacks. But let's go to the Q&A and see. SSS McGrath, if you're only concerned about sprites that exist on more than one cell, why not split the polygons on cell boundaries? There can't be that many, can't be that expensive. Well, I don't know. It's not really necessarily the expense that I was worried about, but it's more just like they're not really polygons, they're upright fake cards. So now you're talking about like splitting the card in based on the 2D, the original 2D, and then redoing it. I guess that would work, and then you sort those separately. I don't know, that's a good question. I mean, I guess we could. Yeah, we could always split stuff. But then again, like inside a cell, you still have to sort them somehow as well. Looks like no Q colons. I am assuming everyone is watching E3. All right, well, I'm going to wind down then. Let me go back here. Thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home, you can always pre-order the game on handmadehero.org, and it comes with the source code so you can play around with it and do your own experimentation. We also have a forum site you can go to ask questions, a Patreon page you can go to if you want to support the video series, a schedule bot which treats the schedule so you know when we're live, and a past episodes archive where you can go to catch up on old episodes. That's it for today. We will be back here Wednesday for the next stream. When I think maybe we'll try the sorting rule and see if we can make it work for us. That's it for today. Until then, have fun programming, and I'll see you guys on the internet. Take it easy, everyone.